of gate? Voltage gated calcium. Okay. So what it said was when the electrical impulse arrives. So that's the part where this has started way up here in the brain and the spinal cord, and we're going to get to all that in the next chapter. But I'll tell you the method is going to be exactly the same, which will make you really happy because you'll realize next time, oh, I've done all this. So that's good. So basically what happens is that this electrical impulse has flipped in this particular area. So the positive has come in. When that positive comes in, I'll draw it this way. First, this calcium gate was closed, but when the charge flipped and the positive got into the cell, it became the trigger, the stimulus, to open up that lid. And as soon as that happened, calcium, which is hanging out here, is going to come in, okay? So what's our next, if we keep going with the paragraph? Again, I'd say wait on drawing for me. Watch this, and then you'll get to, I'll leave it up here, and then you guys can draw it. But let's try to keep, let's just go with the narration first. Okay, next.
Calcium ions move down their gradient, entering the synaptic knob of the motor neuron.
Okay, so they're going down their gradient, which means in order for that to happen, where was the high calcium gradient or concentration to start with? Outside, right? So what type of diffusion is this? Facilitated, because it's going through a channel, right? It's going through a gated channel. Which, remember we talked about how you do all this work to push something out of a cell to create the gradient? So it's ready. And as soon as the gate pops open, then that passive diffusion can happen, okay? So we have calcium coming down its gradient into the synaptic knob. And Sandra, what's next?
The presence of these ions stimulates the ACH of the synaptic vesicles, causing them to fuse with the membrane, releasing their
Okay, hang on, let me pause. There's a lot in that one. Okay, so the entrance of calcium, the presence of it, it stimulates, not ACH exactly, it's going to stimulate a process. Exocytosis. Remember, so we have these these vesicles, and they have acetylcholine in them. That's your ACH. So calcium becomes the trigger. It's like the knobs of the vesicles are like held. And when calcium comes in and binds, it lets them drop. And then they move to the edge and they open up. Okay? So when that happens, so now read that little piece again and put exocytosis in there.
The presence of these ions stimulate exocytosis of the synaptic vesicle,
Yes.
causing them to fuse with the membrane, releasing their neurotransmitter
ACH.
into the synaptic cleft.
There you go. Okay, everybody have that? So acetylcholine is inside the vesicle. The presence of calcium is what drops it, what makes it release. The vesicle fuses with the neuron membrane, opens up and releases acetylcholine into the cleft. Okay? Tia?
The neurotransmitter diffuses across the synaptic cleft.
You gotta read loud.
Sorry, the neurotransmitter diffuses across the synaptic cleft,
Yep.
which binds to its receptors on the motor end plate of the sarcolemma.
Okay, so we have receptors here. These are also going to be gated. These are actually, it's a dual role. A gated channel, so facilitated diffusion, but it also has a receptor on it. So a gated channel that opens when a particular molecule binds sounds like what type of gate? Chemically or voltage?
Chemical.
It's a chemically gated channel, okay? So here, we not only have, let me see if I can draw it this way. So I'll put a receptor there, but this is also a closed gate at the moment. So acetylcholine binds to its receptor, And what's that gonna do to the gate? Open it, like that, right? Now, is acetylcholine going through? No. What's gonna go through? Sodium, okay, so is that the next sentence?
Yeah.
Okay,
The receptors on the sarcolemma are also chemically gated sodium channels.
there we go, let me write that in. I'll do CG for chemically gated. My board is squeaky. Okay, so this is a chemically gated sodium channel. Also, remember double duties. Also acetylcholine receptor, right? So when that opens, is that yours?
Yeah.
Okay. Next, let's say that one more time, Melina.
The receptors on the sarcolemma are also chemically gated sodium channels.
Okay, so now keep going, Shelby.
As the neurotransmitter binds to its receptors, the channels open, allowing sodium ions to quickly diffuse into the sarcoplasm.
Okay, there we go. Remember, sodium is on the outside, here at rest, just like it was here. So now we've opened up a channel. So this sodium that's out here will automatically, on its own, no energy required, it's gonna do what?
Flood in.
It's gonna flood in. So the sodium comes in through its channel. So you see how gated channels work? If it's closed, nothing can happen. As soon as the stimulus happens, it pops open and that triggers this passive flow. That's that domino effect. Like as soon as the gate opens, it just floods in, okay? So we have sodium in here now. All right, Cal, what's next?
As the that's the one you wrote. The resting membrane potential of the muscle starts out as negative 90 millivolts,
Okay,
but the introduction of positive charge reverses the membrane potential and makes the inside of the cell more positive.
okay, so I'm gonna hold on right there. So we didn't put a number to here earlier, so let's do that really quick. All that means is, that's the numerical value for that resting state, okay? So two pieces are important. I'm gonna put this over here, if you guys wanna write it somewhere else. When you're looking at a charge across a membrane, what we're doing is, you're basically taking a sample of the charge on the outside and comparing it to the inside. The numerical or the number here is the numerical difference between the two, okay? So that means like this was 100 and this was 10, right? So the difference between the two would be 90. This number tells you specifically the inside. So we know that the inside is more negative and the difference, the separation, is a degree of 90, okay? So this is our resting state. If we, with what Cal was just saying, when we let sodium in, what's happening to the inside of the membrane charge-wise? It's becoming more positive, right? So it's going to go up. So as sodium comes in, you can see how we are becoming more positive on the inside, and we'll come back to all these numbers later. All right, Karen, let's keep going.
If the threshold is met, there is enough of a voltage change. Nearby voltage gated sodium channels open in the sarcolemma, generating action potential.
Okay, so let me show you what these are. So my green channels are gonna be voltage gated sodium channels. All these blue ones were chemically gated. Okay. remember, voltage gated has a specific stimulus. It's not just any change in charge. It's going to require a very specific change in charge, okay? Do we go into, in this, the specific number of threshold or not? I don't remember.
No.
No? No? Okay, we'll just leave it at that then. That just means that when enough sodium comes in, like
It
let's
says-
say that, what?
It says the reversal one, but not.
Okay, we'll just wait.
Okay.
Like, here's an example. Let's say we had to get all the way to minus 55. Okay, so enough sodium had to come in that you got to that number. That's the key to unlock this gate. So what happens is that as these sodium ions come in, right, they come in and they kind of float around. Well, here, when they get to the inside of the membrane near one of these voltage gated channels, if enough sodium has come in, what's gonna happen? It's gonna open. And what will come in? Sodium will come in. Okay? So Carrie, can you read your sentence one more time while we're looking at this?
If the threshold is met, there is enough of a voltage change nearby voltage gated sodium channels open in the sarcolemma, generating action potential.
Okay. These voltage gated sodium channels, this is really your set of dominoes. Because the way this works is sodium comes in through these chemically gated channels and it opens up that first voltage gated channel. This lets in a ton of sodium, much more than these do. You don't have to know that specifically, but once you open one of these, sodium floods in. And what happens is that you get enough in here to trigger this one to open. Sodium comes in. You get enough to come in to trigger this one to open because they're all voltage gated, and that's your domino. So this entire membrane, all of your sarcolemma, all the way down into the T-tubule, up the T-tubule, out the other side, going in that direction, all over the neuron, like all of these areas are sets of voltage gated sodium channels. So if you can trigger that first voltage gated sodium channel to open, you have set this entire process on fire. Okay, yes.
So the interaction happening in the motor end plate isn't significant, it's just enough to start the chain reaction along the rest of the fiber?
Yeah, it starts the chain reaction, but it's hugely significant
Right.
in that this neurotransmitter is what can physically float across the gap, right?
Right,
'Cause
but
we
it's
don't-
not like all the sodium entering from the motor end plate is what?
Correct, right, it's just enough here to trigger this. And then the membrane is so set up so evenly that you're gonna be ensured that the process just zooms forward and spreads in all directions, okay? Alright, so now this electrical, now once we have this happening, where we have one open, sodium comes in there, it opens this channel, sodium comes in there, right? And this is gonna happen all the way. You don't have to draw these, I'm just giving you the idea, right? Where sodium is coming in. And it opens up the next channel. So you have channels, and in a minute you guys will be drawing these. These channels are all over. These green voltage gated ones. Okay? Okay. Miranda, do you have the next? Or can you look?
So it says the propagation of the action potential involves the opening of successive voltage gated sodium channels
Mm-hmm.
all along the sarcolemma.
Which is what we were just showing, right? These are the successive voltage gated sodium channels, all the way down. Okay, Brittany?
The opening of these channels allow a large number of sodium to diffuse rapidly out of the cell.
These are coming in. Is into an option?
Yeah.
Yes.
Okay, yeah, into the cell,
Into,
good, thank
okay.
you. So it allows a large amount of sodium to diffuse into the cell. And then Amy?
says, what type of membrane transport is this? Facilitated diffusion?
Perfect, yes. Tia?
The propagation can also be thought of as a wave of depolarization, which causes a reversal of RMP from negative 65 millivolts to positive 30 millivolts that spreads along the membrane.
There we go. Okay. So that means our threshold was minus 65. So the reason why we say this is a wave of depolarization, in fact, what did we say polarization was? Right, that separation. Depolarization is like saying we're undoing that. Okay? And so we get enough sodium in that we actually go up and we flip the membrane potential to a positive. Now it's positive on the inside because we've let so much sodium in. Okay? Yeah.
So we need to know that it's negative 90 at rest, negative 65 at the start of excitation, and then
So
positive
plus 30? Yes, I think we do need to have that if it's not written in there. So I'll leave this up so we can make sure.
Well, it's
we
in
get that.
this, but I just
Okay.
like testing purposes.
Yeah, that's your resting number. The threshold is kind of what these voltage gated channels require. So if you all of a sudden had a malfunction in your synaptic knob and you could not release acetylcholine, could you ever open up these channels? No, because the acetylcholine would not open these channels, no voltage change would happen, these would stay closed. That is what Botox injections do. Just so you know.
On purpose or side effect?
Well, so botulism, if you get it from like bacterial infection, right, it would do that. But Botox on purpose, yes, does that. What's the purpose of Botox?
Stop muscles from moving.
Stop muscle
Freezing.
contractions, because those make wrinkles.
That's why you can't laugh. In the movies, they're always making fun of. Like, I don't know which movie it is, but the guy, he's sipping water and he
Yes.
has so much Botox, it just
Oh, and it
drips
just-
out. I forgot. Adam Sandler
Right.
movie?
Yeah.
Right.
That's
Go
another
with it.
thing.
So
Yeah.
you're actually going in and you're blocking
Just go with it.
exocytosis of acetylcholine. It prevents that process so that you don't get muscle contraction in those areas, so that your face is smooth. Okay. All right. That's good to have trivia like that. All right, where are we now? Okay.
As the action potential depolarization spreads to the T-tubules, voltage-gated calcium channels open in the terminal cisterna
Yes.
of the SR.
Okay, we're almost to the end of this. You guys are doing great. Okay, so tell me, what's the terminal cisterna?
That's where all the calcium is housed in the sarcoplasmic reticulum.
Uh-huh. My marker is just dead. Let's try again.
So it's voltage gated calcium ions.
These are, yep, we're now switching to voltage gated calcium channels that are here. Because calcium is stored here. This is a big sac, right? When you look at this model, if you looked at it here, this thing that looks like that crocheted sweater kind of thing, that is all part of the terminal cisterna. So it's this really intricate sac that winds its way all in through all the pieces of the muscle cell, and it stores calcium. These blue lines here are the part of the T-tubule that also gets way down in there. Because what's gonna happen is that we're going to release calcium from this, and it's going to release into the cytoplasm of the cell. It's not going out, it's releasing it from storage into the cytoplasm. And what it's going to come into contact with are all these sarcomeres, which will then lead to some contraction, okay? So, let's see, where are we on our, I'm just looking visually, where,
Just
at the
started.
very end. Okay. Because I know y'all need to stand up. All right, so we have the sodium in here that comes in, right? We've now brought positive inside. It now is the trigger to open this voltage gated channel, right? And if calcium is in a high concentration here, where is it gonna go? Out. So calcium is basically gonna just like fall, you know, like little raindrops, you can think of it that way, into the space of the cell. Okay, so let's finish up this little bit and then we'll stop.
This allows calcium ions to rapidly diffuse out into the muscle cell where it mingles. I've changed it twice. I put sarcolemma and also put terminal cistern, which is the first one, so I'm not really sure.
It mingles through the sarcoplasm, so into the cytoplasm,
Oh, okay.
right? Mingles, that's a good word too.
Oh, it's in the book too. It takes it
That's
from the
good.
book.
Okay, good. And then is that the end of that one?
Yes.
Okay. See, if we stop there, we don't have contraction yet. Look, all of this is before a muscle even moves. So if you hold your finger, you're like, let me bend my finger, right? That's what all has to happen before, like, to get motion. And that all has to start in your brain, which we skipped all of that, to get here, to get all the way down to the T-tubule, and we haven't even touched the sarcomere yet, right? It's just amazing. It's the coolest thing. Okay. But, sorry, that was